Hey, welcome back. So I've had some requests to explain some chemistry, and more specifically, um, the mole road and how do you convert moles to grams and grams to liters. So that's what this and maybe the next video will be about, is how to use. Well, really, the topic will be about moles and the mole road. Moles and the mole road. Okay, so you may be wondering, what is a mole? We'll start off basic. Well, a mole is just a unit used to measure a substance. So we could say there are 2 moles of carbon. That's like saying there are 3 pounds of carbon. Although those aren't actually equivalent, but it's the same idea. It's just a unit. It's a unit that we use to keep track of the amount of a substance. So we could say there are 4 moles of CO2 in the air. So scientists often use a mole to describe the amount of a substance in maybe a chemical reaction or something of the sort. But for practical terms, it's necessary to be able to convert moles to something more familiar like a liter, or convert it into grams, so you know how much in weight of carbon you'll need to add to something, or how many moles of or liters of CO2 you'll need to add. So there are a few, or there's a we can define it like this: in one mole in 1 mole of a substance, there are of any substance. So say you have 1 mole of carbon, then there are 22.4 liters of carbon. So whenever you have 1 mole of any substance, it could be anything, as long as you're at standard temperature and pressure, which for basic chemistry, most questions will be. So as long as you have 1 mole of a substance, 1 mole will always be equal to 22.4 liters of that substance. And so another thing I forgot to mention is 1 mole, in case I keep mentioning specific elements. So you may be wondering, why do we even use the term mole? Why don't we just say there are 6 carbon atoms, or you need 20 carbon atoms to make a specific chemical reaction occur? Well, let me put this into perspective for you. I'm sure you know atoms in general are extremely small, and it takes an extremely large amount of them to actually be applicable to real world situations, unless you're working on a nanoscale or something like that. But most of the time we're not. So just to put this in perspective, 1 mole is equivalent to 6.022 times 10 to the 23rd atoms. These are all one, so 6.022 times 10 to the 23rd. That's six. That's the number 6022 with 23 zeros after that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way up to 23. So this is a huge number we're talking about, and 1 mole is that many atoms. So when you have, say, 1 mole, when you have 1 mole of carbon, you really have 6.022 times 10 to the 23rd carbon atoms. So when we use moles, we're just really creating a simpler way for us to understand how many atoms are actually being used, because this is an extremely large number that we can't really understand. It's just so large, it's beyond our brain power. You might even say that. But so a mole just puts these huge numbers into simpler terms. So 1 mole is equivalent to 6.022 times 10 to the 23rd atoms of any element. And this number right here, this 6.02 times 10 to the 23rd, you may be familiar with it. It's called Avogadro's Avogadro's number. This is a pretty famous number in chemistry. You'll use it a ton. And a scientist with the last name Avogadro created it, so it's Avogadro's number. You should try and commit this to memory, because you'll need it for a lot of these conversions and using the mole road, which we'll talk about in a few minutes. So, back to this. So, 1 mole, 6.022 times 10 to the 23rd atoms, will fill up 22.4 liters at standard temperature and pressure. So, at STP, standard temperature and pressure. So, in grams, if we want to convert moles to grams, 1 mole is equal to how many grams? Well, we have to look at the periodic table of elements to fully to understand this. Oops. And I have one right here for us. And you may or may not be familiar with the periodic table of elements, but basically this bottom number right here, all these little numbers under the letters or the chemical, the element's name, all these numbers represent the grams per mole of a substance. So it changed, as you can see, for aluminum it's 26.982, for silicon it's 0.086, and it changes for all of these. So it's saying in 1 mole of boron there are 10.8 grams of boron per 1 mole of boron. So in 1 mole of nitrogen, there are 14 grams of nitrogen. In 1 mole of selenium, there are 78.96 grams. So it keeps changing, as you can see. So it's very helpful to have a periodic table near you when you're doing these conversions. So let's go back to this. So 1 mole, you have to look to find the number of grams in it. You have to look at the periodic table of elements. We'll just simplify it like that to find the grams, and it's the number right under the element symbol. So with no further ado, we'll go on to some examples of how to convert 1 mole to grams or 1 mole to liter, or to find the atoms of a substance.